In last video, we have seen what are the application of an arrays, and then followed by we have seen that how can we declare the two-dimensional array, and then we have seen the application of an two-dimensional array, that's a sparse matrix. A sparse matrix is nothing but a number of the number of zero elements will be larger than the non-zero elements, something that occupies large amount of memory space in your memory. So to overcome the drawback, we have gone for a triplet representation, where the triplet representation will define that always the column size is 3. That's a predefined one. Always the column size will be 3, but the rows will be depends on the corresponding number of non-zero elements. So for this concept, we will try to write a coding using a C language. Okay. So at first, here for example, if I am going to declare an 4 cross 4 matrix. So here we have taken 4 cross 3, right? So we will take the same example itself, 4 cross 3 matrix. So here the maximum possibility of non-zero elements are here. All the data can be non-zero elements. All the data can be a non-zero element. So 4 cross 3. Okay. So we have 4 rows, 3 columns. Okay, 4, 8, 12. There will be 12 number of data can be in non-zero elements. This is the first possible case. Okay. And second possibility is there will be a zero number of data can be in non-zero elements. All can be a zero element. All can be zero element. So now while writing your coding, at first I will define, since I'm going to take a 4 cross 3 matrix, I'm going to define the max value as a 12. Max value as a 12. The reason behind the 12 is I am going to take a 4 cross 3 matrix. So the maximum, the number of data can be non-zero elements can be maximum of 12. That's the reason behind the 12 value. Okay. So now you start writing a coding. So at first, we will declare the matrix size. So we have taken an 4 cross 3 matrix. So int of and 4 cross 3, and then the B matrix will define the triplet representation. So in the triplet representation, always the column size is fixed to 1. The column size is always 3 columns. 3 columns, row, column, and data. So here in place of uh, column position, I have given 3. But here in terms of the corresponding B in the row position, it will depends on maximum number of non-zero elements. All 12 can be non-zero elements. So max plus y plus 1, because the plus 1 will define the size of your matrix and data, number of non-zero data. So the always in the triplet representation, the first row will defines the size of a matrix 4 cross 3 and how many number of non-zero elements. 3 is a non-zero elements. So that's why I have given max plus 1. Okay, so that's a B matrix. The B matrix is nothing but triplet representation. Okay, so then we will add a variables. Depends on the for loop, we will add in more number of variables. Okay, so I will leave this as a continuous. We will add it whenever we require. So now at first we will ask the user to enter the order of matrix. Okay, we will ask the user to enter the order of the matrix. So here we have declared size as a matrix as 4 cross 3. So here I can do it for 1 1 or 1 2 or 2 2 or 3 3. I can do it. Maximum of 4 3 I can do it. Beyond that I can't do it. Okay, that's what I have allocated memory space. Okay, the two-dimensional array has been allocated for 4 cross 3. 12 memory space has been allocated. So within the 4 cross 3, I can do the matrix of size of an order of 2. Okay, both rows and columns, 2 2 or 3 3 or 1 2 or 2 2 or 2 1, wherever possible I can do it. Okay, so that's why I'm getting order of matrix. There will be confusion that already we have given 4 cross 3, then why are getting order of a matrix over here? The maximum space or the maximum size of a matrix can be in 4 cross 3, but still I can opt for an lesser order of matrix also. Sometimes 3 cross 3 or 2 cross 2, I can do it over here. So that's why I'm getting the data from the user that which order you want. Okay, so then I will scan those datas. And then for row, I will intimate by means of R, and then for columns, I will intimate by means of C. So I should add two more variables called an R comma C for row and column. So now here I have gotten matrix size as a, for example, 3 cross 3 has been given by the user. 3 cross 3 is given by the user. The maximum size is 4 cross 3, but as a user, I'm opting for 3 cross 3. That's why I given as 3 cross 3. So once I give 3 cross 3, I have got the order of a matrix. So now I should enter the data over there, right? So to enter the data over there, I should get here data from the user. So for that, we will use a for loop. So I require an corresponding two more variables. I is for an row and j is for the column. Okay, so let me use I is equal to 0. The initial condition I is equal to 0. And then, so the I will enter the data. The data can be entered into one rows until maximum of row size. So 3. Until 3 comma 3, I will enter the data, right? So I less than R. I less than R. And then I will increment the I. I will increment the I. Then once again, I'll do it for an corresponding column. J is equal to 0 and J less than column and J plus plus increments. So I have declared two more variables called in and j. So now what I will do it over here. So correspondingly, I will start to put the data over in a corresponding rows and column space. So scan of percentage D. So I will store the data in place of I and j. I will store the corresponding data. So in the first case, what happens over here? For a is equal to 0, for a of I comma j, for I is equal to 0, and for j is equal to 0, we will store the first data 0 comma 0. The first data will be stored as a something called 0. And then the second case, the I is 0, I will be 0 once again, and then j will be incremented to the 1. Then I'll store the value called and corresponding to. Then I is equal to 0, and then j is equal to 2. J is equal to 2. Then I'll store the value called 0. So likewise, I'll be keep on entering the data. So the first row is filled 0 0 0 1 and then 0 2. The first row is filled. Okay, 3 columns and then the first row is filled. Likewise, I will keep on filling the whole 3 cross 3 matrix. So here, what I done over here, I have declared an two-dimensional matrix. Two-dimensional matrix has been implemented using a C language. So at first we have got the order of the matrix, and then we have got the corresponding data for the matrix. So now once we got the matrix, then now we will change it to the triplet representation. So for triplet representation, what do we do? The triplet representation, the matrix is B matrix. The matrix is B matrix. So now in the B matrix, always the 0, 0. The 0, 0 will always define the number of rows, and 0, 1 will define the column, and then 0, 2 represents the number of non-zero elements. So here I will declare the B matrix nothing but triplet representation. B of 0 and 0 will define the row, and then B of 0, 1 will define the column. Understood? The first row is okay. Number of the first row is nothing but an and corresponding the triplet representation. The first row is always taken for the size of a matrix. So here in our example, the R value will be 3 over here, and column value also will be 3 over here. As we given here 3 cross 3, the row value is 3 and column value is 3. The triplet representation. So now here, let me take one more for loop, because correspondingly I should enter the sparse matrix triplet representation table. So once again, for I is equal to 0, for I is equal to 0, I'll copy it from here, because I need to traverse through the sparse matrix. Okay, one by one. Whether I'll go and check it out at first, whether the element is 0 or not. If the element is not 0, I will go and store it in the triplet representation table. If it is 0, I will go for the next data. That's the logic behind this. So here, after the for loop, I will be in the position called an a of 0, 0, a of 0, 0. So at first, what should I check? In the sparse matrix, I'll go and check whether the element is 0 element or non-zero element. If it is non-zero element, I will store it in the table. If it is 0 element, I will skip the corresponding data. So I will check for if a of I, j is not equal to 0 or not. Not equal to 0 or not. If it is not equal to 0, then I will store the data in the corresponding triplet representation table. Okay. So now let me see, take an example over here. So we are doing for 3 cross 3 matrix. So 3 cross 3 matrix we have taken. So here these are the datas we have: 0, 1, 0. So this is the matrix. So for this matrix, we have to form an triplet representation. So the triplet representation always the column size is 3, and then the row is maximum. Maximum plus can be 1. So now what happens over here? The first row will always defines the number of rows and columns and the size of your matrix. So here the number of rows is 3 and column is 3, and number of non-zero elements are 1 and 2. So there are two non-zero elements. This is the first row. So now here this is done. The B of 0, 0 is done. B of 0, 1 is done. 3 and 3, and then non-zero elements are 2 here. This is done. So now I'll come to the for loop. I have come to the I0 and J0. So this is 0, 0 position in a matrix. 0, 1. 0, 2. Likewise 1, 2. So here I have given the matrix question 0, 0, 0, 1. So after this loop, at first what happened? I is equal to 0 and j is equal to 0. So here a of 0, 0. So a of 0, 0 is equal to 0 or not equal to 0? It is equal to 0. So now, if it is not equal to 0 only, whatever we are going to write over here will be get executed. So now if it's not equal to 0, it's equal to 0, right? So this loop will be completed. So now it will go for an j is equal to 1. J gets incremented. So 0, 1. So a of 0, 1. So it's not equal to 0, right? So its a value is 1 is there. So it is not equal to 0. So now where should I put it over here? I should put this value in the triplet representation. The first value is 0. And then here 1 is a column value. Then data value will be 1. So I should transform this value into the triplet representation table. So here I'm going to include one more variable called an k. I'm going to include one more variable called an k. K is equal to 1. Why k is equal to 1? Because always the first row is taken for the size of the matrix and data. So to start from the second row onwards, that means k is equal to 1. So now here I'm going to declare here itself k value as a 1 by default. So now here b of k. So now here the k value is corresponding to 1, and then it will go and store it in the first row equal to I, and then b of k, and then the second column, so 1, to store the size of to store the value of a column j, and then b of k and 2, it will store the value of the data which we have in the a of I comma j. So once it is done, I will increment the k by 1 position. So now here we can observe that at first k of 0. So what's the k value here? The k value is 1 over here. So in the B matrix, in the 1, 0 position, this is the 1, 0, the first row and 0th column. This is the 1, 0 position, first row, 0th column. So in the first row, 0th column, so here what happens over here? In B of k of 0 is going to be I value. What's I value here? It's a 0. So I'm going to put a value called 0 over here. And k of 1 is equal to j. What's the j value over here? It is a 1. So the 1 will be put it over in the k of B of k1. And then in the B of k2, I should put the value of the corresponding a of 0, 1. The value is 1. I have put a value called 1. So once it is done, I'll increment the k by 1, so that it will go to the second next row. K is equal to 2 now. So then I will check for this a of I comma j, it is 0. So it will not go into the loop. Then it comes over here 2. So now it will check for the 0, 1. So now here 0 and then 1 column position, the value is 2. Okay, so this is how the corresponding values will be taken. Okay, but here the number of non-zero elements will be taken directly. I don't know how many number of non-zero elements, right? So at last, what's the k value here? At last, once this is completed, the k will be increments to the 3. K will be increments to the 3. Once this loop gets over, k will be incremented to the 3. K is equal to 3, right? So now number of non-zero elements are k minus 1. K minus 1. So in this position, 0, 3 position, I will store the k minus 1 as a value. What's the k value here? K value is 3. So since k value is 3, 3 minus 1, 2. So there are two number of non-zero elements are there. So in the place of B of 0 and 3, I will store the k minus 1. So this is how I can write the programming for an sparse matrix declaration and then triplet representation. In the first half, we have taken a sparse matrix implementation here, and then in the second part, we have taken a triplet representation over here. So then in the once triplet representation over, then at last we will fill the number of non-zero elements in the corresponding 0,3 position. So this is how we can do the sparse matrix and triplet representation.